All right. Good evening, everybody. My name is Kara Manovich. I'm Events and Outreach Officer at the Dunlap Institute for the University of Toronto. I'm so excited that you're back with us for another edition of Cosmos from Your Couch. I'm super excited about tonight's presentation. It's a bit different, which is very exciting for us this evening. We have Assistant Professor Jeremy Webb. He's a member of the Department of Astronomy and Astrophysics here at the University of Toronto. And he is going to share with us, astronomy and Shakespeare. What was astronomy like in Shakespeare's time? How do the beliefs that people thought they knew about astronomy, how are they different in Shakespeare's time as to what we believe now? How did he use those writings or how did he write about astronomy in his works? So there's a fabulous presentation. It's, I hope you enjoy it as much as I did. Once again, I cheated. I saw a little preview, but I can't wait to see it again. So without further ado, I'm going to turn it over to Jeremy. As his presentation is going on, feel free to pop a question in the chat or anything you want to say hi to us, ask us anything about, Dunlap Institute or U of T or astronomy, and we'll have a good time. So without further ado, please welcome Jeremy Webb.
Perfect. Thank you very much for the very kind introduction. So hi, everyone. My name is Jeremy, and I'm a professor at the U of T in the Department of Astronomy and Astrophysics, as my kind introduction alluded to. Now, my research is centered around gravitational dynamics, where I study how black holes, stars, and star clusters interact with their own galaxy. However, as a bit of a side project or a passion project of mine, for a few years now, has been looking into how William Shakespeare makes use of astronomy in his work. Now, this project started a few years ago now when I was a graduate student working at the McMaster Planetarium. Rob Cockcroft, who was leading the planetarium at the time, and our group were kind of brainstorming possible public show ideas, and Rob suggested looking into the astronomy of Shakespeare, which personally I immediately jumped at because I love studying how astronomy is used in works of fiction. However, I'll be the first to admit that English was definitely not my strong suit in school. I enjoyed reading Shakespeare, but I wasn't really the biggest fan of analyzing his works, and I found that a really tough thing to go through. However, as my Aunt Margaret, who is a writer, would tell me, if you can find a way to connect something that you're passionate about to what you're writing about, the writing stops feeling like work and really starts coming naturally. And I think that's what really happened to me as I started looking at Shakespeare through the eyes of an astronomer. Because astronomy and astrophysics is definitely something that I've been passionate about for a long time. And it also helped that once I started doing a little bit of digging around, I realized that astronomy was used heavily by William Shakespeare. Now, it's actually been said that nowhere is there to be found such an abundance of astronomical allusions as occurs in the writings of Shakespeare. This has led to suggestions that Shakespeare had a keen interest in the heavens, as they were called at the time, and that while there's literally hundreds of individual references in his works, I'm going to kind of talk about some of the more famous and interesting of his references here tonight. So we're going to start by looking at the state of astronomy during Shakespeare's times, and then tour our solar system through his eyes and through his work. I'll apologize in advance for any mispronunciations or poor acting skills. I gave up acting in grade 6, and I really haven't looked back. And if you have any questions whatsoever during the show, please definitely put them up in the chat, and I'll answer them as best as I can. So as we embark on our study of the night sky through Shakespeare's eyes, let's set the tone a little bit here and say goodbye to the sun, as Shakespeare does in Henry VIII. I have touched the highest point of all my greatness, and from that full meridian of my glory, I haste now to my setting. I shall fall like a bright exhalation of the evening, and no man see me more. And now let's watch the night sky pass with one of Shakespeare's more poetic descriptions of the night sky from The Merchant of Venice. How sweet the moonlight sleeps upon this bank. Here we will sit and let the sounds of music creep in our ears, soft stillness and the night become the touches of sweet harmony. Look how the floor of heaven is thick inlaid with patterns of bright gold. There's not the smallest orb which thou beholdst, but in this motion like an angel sings. Clearly, Shakespeare is dedicating a lot of time, a lot of words, and a lot of passion towards just simply describing the night sky in this passage. And I think that passion continues throughout his work. So if you look a little closer at the words that I just spoke there, Shakespeare refers to something called celestial music and the music of spheres. Now, to a modern day astronomer, this statement would be very confusing. What are these spheres that Shakespeare speaks of? To answer the question, let's take a moment to kind of step back in time and put ourselves into the world of William Shakespeare. William Shakespeare was born in 1564 in England, and then he has a period in his life called his lost years, this 1585, 1592, when he was a young adult. And we call it his lost years because there's really no mention of him in any records of any sort. But this is believed to be the period that he initially started writing, because it was in 1592 that Shakespeare's plays began appearing on the stages in London. So what does 1592 mean to an astronomer? Well, at that time, there was what was called 7 wandering bodies in the night sky. These included 5 planets, as well as Earth and the Moon. Now, most of Shakespeare's references to the planets were astrological in nature as opposed to scientific. So Mercury was always associated with trickery, Venus with love, Mars with war, and Saturn with evil. The idea that Earth was the center of the universe was only just starting to decline with the work of Copernicus, who kind of led us away from that idea, not being published until the late 1530s. But this work was not something that was considered common knowledge, and still had quite a few skeptics in the astronomical community. But in the Earth-centered universe, as you can see in this diagram, you have the Earth at the very center, the Moon going around it, and then each of the planets and the Sun all orbiting around us. And this is what led to the idea of celestial spheres. It's a direct reference to the commonly accepted theory at the time that the stars and planets are actually fixed objects, but they're fixed on a rotating sphere made of some sort of transparent fifth element. So you picture the Earth here, again at the center, with everything going around it attached to circles. So the closest is the Moon, and then moving outwards, you get to Mercury and Venus, and then that's where the Sun was believed to be, and then Mars and so forth. The outer circle, or more accurately, an outer shell, consisted of stars. The stars were then fixed to this shell, and the shell rotated. Now, these ideas came about because the distances between stars appeared to be unchanging, so their locations must be fixed. Hence the term star-crossed lovers from Romeo and Juliet. 2 stars that are apart in the night sky, it will be their destiny to always remain apart since they are fixed on one of these celestial spheres. Now today, we know that Earth and planets orbit the Sun, and the Sun orbits as one of many stars around the center of our galaxy, Milky Way, which what this video from a simulation is showing. So to be star-crossed lovers today is not quite so tragic, as 2 stars that are on opposite sides of the night sky could appear together in the future because they're both moving, albeit millions of years ago from now, or millions of years from now, but still not forever apart. But back in 1592, star-crossed lovers meant never to be together. So already we have one of Shakespeare's most famous lines, and a complete discrepancy between our view of astronomy today and the view of astronomy in 1592. And if you try to interpret it as a modern day astronomer, it doesn't quite have the same level of impact as it once did. There are more examples of Shakespeare referring to the Earth-centered universe in A Midsummer Night's Dream, where he wrote, "All believe as soon as this who earth may be bored, and that the Moon may through the center creep and so displease." This implies that the moon and her brother, the sun, revolve around the Earth. Similarly, from Troilus and Cressida, the glorious planet Sol, in noble eminence enthroned. So the planet Sol, that's referring to the sun as a planet, not something special or not something that sets it aside from the Earth. It's just another planet that happens to go around us. But it's been speculated that Shakespeare includes passages like this because this was the view of the general public at the time. A closer look at his writing shows signs that he had a deeper understanding of astronomy and was aware that astronomers are moving away from this Earth-centered view of the universe. For example, in this passage from Henry VI, Shakespeare writes, "Mars is true me moving, even as in the heavens, so in the earth to this day is not known." And he's showing here that he's aware that the Earth-centered universe theory had some flaws. Because what Shakespeare is referring to is the motion of Mars in the night sky over time. So the way this little video works that I'm showing is we're looking at a small patch of the night sky. So a lot of those little dots are stars, and they have their little names beside them. You see the ecliptic, which is the motion of the sun across the night sky. And then it's showing the path of Mars. When I say the path of Mars, I mean you would have to go out every night at the exact same time and mark the location on your sky map of where Mars is. And you do that over and over and over again at the exact same time every night to see the true motion of Mars in the solar system, right? You're trying to compensate for the fact that the Earth is rotating and trying to get what Mars's true motion around you is. And when you do that, you see that Mars goes through this period where it's moving the opposite way. So in this video, it starts moving from right to left, which is the same direction as all the stars are moving across our sky. But then it goes through this period of what we call retrograde motion, where it's actually moving backwards. And this is kind of weird. How can it move across the sky, do this weird little loop, and keep going? This really doesn't coincide with this whole idea of celestial spheres and Mars being a fixed object on a sphere. Now today, we know the reason behind this peculiar behavior, this retrograde motion, is simply because the Earth and Mars both orbit the sun, and the Earth has a shorter orbital period. So when it catches up to and passes Mars on its orbit, you get this behavior. And that's what this little video here is showing. The Earth is the inner planet, Mars is the outer one, and then in the top of the little animation is our view of where Mars is on the night sky. And so you can see this little loop, this retrograde motion is very easily explained in a sun-centered solar system. But it really wasn't until 1610, 4 years before Shakespeare's death, that Galileo Galilei was able to provide any scientific proof that the Earth was not the center of the universe. He specifically looked at the phases of Venus. That is to say, Venus has very similar phases as our moon, which we will see later in this talk. And the only way that you can explain there being a full moon at Venus, a half Venus, or a quarter Venus, the same way we have our moon, is if there's a sun, if the sun is the center of our solar system. That was this heliocentric solar system. So to explain the motion of planets in an Earth-centered universe, which is on this plot on the right, as you're going to see when I start the animation, you need some very complex planetary orbits. Right, so just comparing heliocentrism to geocentrism, left versus right, you can see the sun-centered solar system orbits can be pretty straightforward. Everything can have a near circular orbit going around the sun, and the motions of planets in the sky can be explained, and you don't need any complex orbital dynamics. But if you want geocentrism to be correct, planets have to undergo these very strange, very complex orbits to reproduce their motion on the night sky. But the planets weren't a complete mystery to Shakespeare. For example, in this passage from Venus and Adonis, O thou clear God and patron of all light, from whom which each lamp and shining star doth borrow, the beauteous influence that makes him bright. It's clear here that Shakespeare knows that the planets reflect sunlight and don't emit their own. So this statement means that the sun is something special. It's not just one of the other planets. It's its own special thing that is unique and kind of is a sign of stepping away from the Earth-centered universe and towards a sun-centered one. Going back to what 1592 meant for astronomers, at the time, the majority of astronomy just was done with the naked eye. And so it makes sense that the brighter stars were studied the most. They are easier to see. And perhaps most intriguing of these stars was the North Star, also called Polaris. So with the naked eye, the North Star, located in this diagram here at the top of Ursa Minor, is one of the brightest stars in the sky. And it was very confusing back in the 1500s why this particular star doesn't move in the sky while the rest did. Again, if we're following this whole concept of everything being fixed on a celestial sphere, why does the North Star not move? Well, now we know why at present day the North Star doesn't move. And you can really get a sense of it by just looking at this long exposure image here on the right. Or you could think of it as just taking a video of the night sky and then adding all those frames together. Here you can see individual stars moving across the night sky over time, but the North Star, which is at the kind of top center of this image, remains fixed in its location. And you can understand this behavior by simply just doing a little experiment in your own home. Find an open space, stand up, put your arms out for balance, look straight ahead, and start spinning. Now the room around you, which is fixed in location, similar to the way distant stars appear fixed to us, will move around you. And it moves around you for the same reason that stars move across the sky at night. But if you look up at the ceiling, directly above you, there's a central point that is not moving. This point is aligned with what we call your rotation axis, this imaginary axis that you're spinning about. And so it just so happens that Earth's rotation axis, there happens to be a really bright star there, so it doesn't appear to move. Now, Shakespeare used in his writing the constancy of the North Star, perhaps most famously in Julius Caesar. But I am constant as the northern star, of those whose true fixed and resting quality there is no fellow in the firmament. The skies are painted with unnumbered sparks, they are all fire, and every one doth shine. But there's but one in all doth hold his place. Here Shakespeare has used the northern star in one of the most important scenes in Julius Caesar. So despite 3 separate warnings that his life would be in danger were he to go to the Senate that day, he will not change his mind. And he goes to compare himself to the brightest and constant star of all. A minor spoiler alert for Julius Caesar, that doesn't end well for him. And he probably shouldn't have gone to the Senate that day, and he should have heeded those wishes or those warnings. And so it's perhaps a little ironic then that the Northern Star truly is not constant, just like Julius Caesar. Not only does it actually wander within 1 degree of true north, it in fact, the Earth's rotational axis itself processes a bit like a wobbling top, as I'm trying to show in this diagram here. And the period of this wobbling top is about 26,000 years. So for the most part, day to day, and within the majority of our lifetimes, well, all of our lifetimes, the North Star will always be the North Star. The Earth will rotate once every day, pointed in with the rotation axis pointed directly at Polaris, plus or minus a degree. But over time, that's slowly going to change. So you can imagine someone in grade 10 English, 13,000 years from now, reading Shakespeare. This particular passage would be extremely confusing because the North Celestial Pole will be pointing in a completely different direction than it does now and might not necessarily line up with any particular star. There might not be a North Star anymore if you wait a long enough time. Another reference to the constancy of the northern star can be found in Othello, where a character describes a storm at sea. In this quote, the wind-shaked surge with high and monstrous main seems to case water on the burning bear and quench the guards of the ever-fixed pole. So here the burning bear is the Great Bear constellation lying near the horizon, while the guards of the ever-fixed pole are the two stars Beta and Gamma of the Little Bear. So while Shakespeare is still noting that the North Star is constant, he's also using the night sky and constellations to set both the scene and the mood. While we're on the topic of constellations, Shakespeare was actually quite well known for using the constellations to tell the time, since at night you can't use the periodic motion of the sun. For example, in Henry IV, the character known as the Carrier says, "Hey ho, an't be not 4 by the day I'll be hanged. Charles's wain is over the new chimney, and yet our horse is not packed." Now, Charles's wain was a popular name at the time for the principal stars of the Great Bear constellation that we know today as the Big Dipper. And so from where the Carrier's standing, the Big Dipper is just rising over the chimney. And this gives you a sense of what time it is at night and how much time they have left. Perhaps now a less obvious reference is another one found in Henry IV. "We that take purses go by the moon and the 7 stars, and not by Phoebus." This refers to the fact that the thieves prefer moonlight as opposed to the light of the sun for their activities. It is debated whether the 7 stars in this quote simply refers to the Big Dipper and is again just marking the time of the night, or if the 7 stars refer to the 7 sisters, daughters of Atlas and Pleiades in Greek mythology, and that the thieves superstitiously rely on the well-known good luck that is associated with the 7 bright stars that are called the 7 sisters to favor their activities. Now, what's really cool about the 7 sisters is that they're actually the 7 brightest stars in an open star cluster, known today as M45, although you might be more familiar with it as it's called the Pleiades. And if you drive a Subaru car, you're probably really familiar with it, because it's probably on your hood. The next 2 brightest stars after the 7 sisters are their parents. And so even though we typically only see with our eyes in the night sky the 7 bright stars and maybe their 2 parents, they're actually stars that are a member of a cluster that contains over 1,000 stars spread out over 43 light years. They're extremely hot, which is why they have this blue color. And the cluster that they're in still contains a lot of gas and dust that new stars are forming out of. And so it reflects that light and gives it kind of this blue hazy look, which is really interesting. However, it wasn't until Galileo looked at the 7 sisters with a telescope in 1610 that we knew that there were more than just 7 stars in that part of the sky. Now, constellations, and specifically astrology, were prevalent in the works of Shakespeare. But many argue that this is only because his stories span nearly 200 years of history, and they had to properly reflect the beliefs of the time. However, his belief that the heavens may have a more scientific explanation and can't control the events which take place on Earth is evident again here in Julius Caesar, where it says, "Men at some time are masters of their fates. The fault, dear Brutus, is not in our stars, but in ourselves that we are underlings." And I think we already had someone in the comments bring up this particular quote, so that was great foreshadowing. And he hints at a more scientific explanation for the stars themselves in Hamlet, where he writes, "Doubt thou the stars are fire, doubt thou the sun doth move, doubt truth to be a liar, but never doubt I love." So he's treating the stars in the night sky through a more scientific point of view in both of these quotes. Again, kind of a bit of a departure from the traditional view at the time, or the more astrological view of the stars in the night sky. Now, we still haven't gotten to the biggest and brightest object in the night sky. I've mostly been talking about stars and constellations, but there is, of course, our own moon. And in his work, Shakespeare alludes to the moon in a few different ways. The monthly cycles of the moon, eclipses, and surprisingly, control of the tides. Now, the fact that the moon is responsible for the tides on Earth was actually not common knowledge at the time in the late 1500s. So it's kind of a big deal that Shakespeare was aware of this. And how he discusses all three demonstrates that he really must have been aware with the more scientific explanations of the moon, earth, sun system. So for example, in Timon of Athens, he writes, "How came the noble Timon to this change? As the moon does by wanting light to give, but then renewal I could not, like the moon. There were no suns to borrow of." Shakespeare's showing here his understanding that the moon shines by light reflected from the sun, not from light it generates itself, which perfectly explains the phases of the moon, or as I referred to it before, the monthly cycle of the moons, which we know today to simply be the result of the moon orbiting around the Earth, which in turn orbits around the sun. So in this diagram, you can imagine sunlight coming from the top left corner of the image. And then the person in the middle is someone standing on Earth, looking straight ahead. And then it shows the different locations of the moon and what phase we would view them in. So if the moon is between us and the sun, like in the top left image, we get a new moon, which is out during the day. However, if the Earth is between the sun and the moon, then we get a full moon, and its full face is lit up in the night sky. And then for different orientations, you get different phases of the moon. Now, these different phases, the cycle of the moon, was typically associated with qualities of fickleness and instability. For example, from Romeo and Juliet, Juliet says, "Oh, swear not by the moon, the inconstant moon, that monthly changes in her circled orb, lest that thy love prove likewise variable." So not only is it saying, don't swear to me by the moon, because the moon is constantly changing, but Juliet's also again referring to this circled orb and still referring to this concept of everything being fixed on its own sphere, these celestial spheres. So again, interpreting a passage like this as an astronomer, or even just a human being of the 2020s, the meaning of this passage changes a little bit. Shakespeare was also aware that the moon's orbit was not a perfect circle. It's technically a little bit of an ellipse, sometimes coming closer to the Earth, sometimes farther away, just by a little amount, and something we really only notice if you're taking a close look at it, likely with a telescope or some very strong binoculars. And he typically referred this to the air of the moon, and he associated it with lunacy. So in Othello, it's said, it is the very air of the moon. She comes more near than Earth than she was wont, and makes men mad. Eclipses also seem to occur very frequently in the works of Shakespeare, often as a sign of evil. So here I'm showing a lunar eclipse where the moon passes into the Earth's shadow. So it is obviously on the opposite side of the Earth as the sun, so this would be a full moon. But not every full moon results in a lunar eclipse. The moon has to be perfectly aligned with the Earth and the sun to pass directly into the Earth's shadow. And this is when we get these really dark red images of the moon in the night sky. Now we know for certain that Shakespeare would have observed at least one total lunar eclipse in London, which occurred in September of 1605. And perhaps that was the inspiration for this quote. "Alack, our terrene moon is now eclipsed, and it portends alone the fall of Antony." And of particular interest is this line from King Lear. "These late eclipses of the sun and moon portend no good to us." Now I say it's of particular interest because this play was first performed before King James at Whitehall in Christmas 1606. only a few months after a total solar eclipse had actually been observed in London. So a solar eclipse is when, now in this scenario, the moon is now between the sun and the earth. Again, in general, the moon is between the earth and the sun once a month during a new moon. But when they're properly aligned, the moon can actually block out some of the sun's light. And this happened in London in October of 1605. Now, when this occurs, it gets extremely dark during the daytime, and you can even see stars. So here's an image shot from space of a region on Earth that is experiencing a total solar eclipse. As you can imagine in this play, and when it's daytime, and then all of a sudden it just gets very dark during the day, and it really kind of sets the mood and I think foreshadows some sort of coming of evil. And the fact that Shakespeare saw one of these and then used it in a play merely months later meant he was pretty keeping up with what's happening in the world of astronomy from the day to day. And then, as I mentioned before, he just demonstrated a really remarkable understanding of tides. So in this quote from Hamlet, he writes, "The moist star under show's influence Neptune's empire stands." Where the moon is the moist star at the seas, and the seas are referred to as Neptune's empire, because he was god of the sea. He also referred to the moon as the governess of floods in Midsummer Night's Dream. Understanding this relationship between the moons and the tides was very remarkable. So in general, our picture of the Earth, both in the 15 and 1600s as today, is that it's this nice blue sphere. With a little bit of, a little bit of land on there, but for illustrative purposes, it's this nice, perfect sphere in space. And this would mostly be the case if it wasn't for the moon. The moon actually exerts a gravitational pull on the Earth that results in it not being spherical, as it's shown here, but actually slightly more oval in shape. Now, this image is slightly exaggerated, but it's showing you that the Earth, along at least the line connecting the moon and the Earth, is stretched out. It's more oval in shape, more of an ellipse. And water responds to this oval shape in such a way that if you're on the stretched out part, so something over, if you're on this part of the Earth, which is being pulled towards the moon, this part of the Earth experiences high tides on the left in this diagram where I'm trying to show with this laser pointer. Similarly, the right side here will also experience a high tide because it's stretched out in the oval shape. But here at the center where I'm pointing, and then on the opposite side that's out of view, you would experience a low tide. So different parts of the Earth are being stretched out and then returning to normal every day. This causes the height of large bodies of water to rise and fall twice per day. Now, in the late 1500s and early 1600s, the scientific reasoning was hotly debated. Galileo had actually published in the late 1500s that the tides were due to the gravitational interaction of the sun and the Earth. Although this failed to explain why we see tides twice per day instead of just once, although Galileo blamed it on factors like the shape and depth of bodies of water. Another astronomer, known as Kepler, turned out to have the correct idea here, and he was the first to suggest that the moon was responsible for tides around the same time. This kind of scientific work, though, was going on literally at the same time as Shakespeare was writing. And there's no such thing as Google back then. You can't quickly post a scientific article for everyone to read, can't tweet new discoveries. So it meant that Shakespeare was following scientific theories and discoveries as they were happening, possibly reading scientific journals to remotely have an understanding of what the true meaning behind tides were. Now, everything else I've discussed had some basis of scientific understanding in the 15 and 1600s, sometimes wrong, but there was some theory at the time to explain everything that we were seeing. But other astrophysical phenomena remained unexplained. Things like comets, meteors, and even supernovae represented unknown entities in the field of astronomy. Now you should be thinking right away, what? Supernovae? Did astronomers, let alone the general public, know what a supernova was? Because this should seem very surprising. And it turns out they didn't. But a rather coincidental reference is made in Hamlet, with one guard describing the time when he last saw the ghost to the other, and he says, "Last night of all, when yon same star that's westward from the pole had made his course to illume that part of heaven where now it burns, Marcellus and myself, the bell then beating one." So the guard is saying that a star has appeared and started lighting up part of the sky that didn't used to be there. Now it's believed that this illumination of the star is actually a supernova and corresponds to the second most recent supernova occurring in the Milky Way that would be visible to the human eye in 1572. And it likely appeared in the night sky as a very bright object and then slowly faded over the next few days and weeks. While definitely unknown in the 1500s that a supernova is the final phase of a massive star's life and that they end their lifetime in giant explosions. So what happens in a massive star is that it runs out of fuel and then it's no longer able to undergo nuclear reactions in its core that generate energy. When this energy generation stops, the star collapses until it's so dense that it can't collapse any further. The infalling material that is traveling extremely fast rebounds against this stoppage in a very energetic fashion, leaving behind a remnant gas cloud. Now, there's no way that Shakespeare could have known all of this and that this is that he was seeing the death of the star. But it's rather interesting that he observed the brightening of the star in the night sky and then its eventual fading and disappearing. And he worked this into his plays. And here, maybe I'll show that video one more time because it's such a nice one and I won't talk over it. So I'll let you maybe just enjoy it. And now it's important to look here at what this remnant gas cloud looks like. This is something that more or less maintains its structure for a very long time, which means we can look where this star was observed in the night sky many years ago in this scientific paper. And we can point telescopes there and actually look for evidence of a supernova remnant. Amazingly enough, not only did we find this remnant, which was the Tycho supernova, which occurred in 1572 when Shakespeare was 8 years old. But amazingly enough, a second supernova occurred during Shakespeare's lifetime, with its remnant illustrated here on the right, the Kepler supernova from 1604. Now, this is truly amazing that William Shakespeare witnessed 2 supernovae during his lifetime. On average, a supernova occurs twice per century per galaxy. The Milky Way has been a little lazy with its supernovae because the Kepler supernova in 1604 was the last one to occur in the Milky Way. So probably the last one that we could see with our eyes at night. There was one in 1987 that occurred in a nearby galaxy that orbits the Milky Way, but nothing has occurred in the Milky Way since 1604, even though we expect maybe another 8 or 10 to have occurred. So it's pretty cool that he both observed 2 supernovae events while not knowing they were supernovae. He worked them into his writings. Now, fast forwarding to present day for a second, astronomers have been keeping a watchful eye on a nearby star named Beetlejuice. It's a massive star that is very, very large, so about 770 solar diameters. As you can maybe see in the top scale here of this image, that puts it out to the size of beyond Mars's orbit, almost Jupiter's orbit. So if the sun was all of a sudden replaced by Betelgeuse, Mercury, Venus, Earth, and Mars would be inside of that sun. And then it's also significantly more massive, about 20 times more massive. And these features, these properties, are indications that it's near the end stages of its life. For a while, this past winter, it was starting to dim, and this got everyone very excited that a supernova explosion was imminent, and the star ended up gaining its own Twitter feed with daily updates, letting you know, hey, I'm still a star. I haven't exploded yet. But it's kind of rebounded from that dimming, and it's getting bright again. And it was actually suggested very recently, like within a week or two in a paper, that the dimming was just due to a massive outburst by the star. And it's back to being this large, massive star that perhaps isn't undergoing supernova anytime soon. But whenever it does go supernova, it will be the first time in history that astronomers will have been able to study a star before and after it goes supernova. Because while present day we still observe supernovae in other galaxies, we typically can't see the star until after it's exploded. So whenever this occurs, it'll be a huge help for astronomers in our ability to predict how and why supernova happen, and start kind of generating theoretical models based on those observations. So that'll be a pretty exciting time. Now, I also mentioned that comets represented a bit of a phenomenon in Shakespeare's time, which is kind of timely, considering we have Comet Neowise has been up in our night skies as of recently. And you can imagine why these would be surprising, right? You have this amazing poetic description of the cosmos where everything is fixed to its orb, fixed to its celestial sphere, and those spheres rotate around the Earth. And now all of a sudden you have something that, again, is kind of similar to a supernova, shows up, starts getting bright enough in the night sky to see, eventually develops these long tails, and just hangs around in our night sky for several days or weeks, depending on the comet. So this would be something that'd be very confusing and really breaks this idea of celestial spheres. Now we know now that comets originate from something called the Oort Cloud, this huge spherical cloud of pretty much icy snowballs that's around our entire solar system. And so what's actually happening is that comets that are in the Oort cloud that happen to pass near the sun have really, really long orbital periods. That's to say they'd come close to the sun anywhere between 100 or every 1,000 years. Or some sort of collision and gravitational interaction in the Oort cloud sends the comet hurtling towards the sun for a single pass, never to return again. But from Shakespeare's point of view, this whole situation, this whole concept really breaks the natural law of behavior of things. And these objects just simply appear, approach the sun, and light up, then disappear to never be seen again. For this reason, comets are usually associated as omens of disaster or signs of divine displeasure. Again, from Julius Caesar, now shine it like a comet of revenge. A prophet, oh no, not from Julius Caesar, apologies, Henry VI. Now shine it like a comet of revenge, a prophet to the fall of all our foes. And then again from Julius Caesar, when beggars die, there are no comets seen. The heavens themselves blaze forth the death of princes. So it's saying when a prince dies, this is a divine displeasure. They're upset that such an amazing, such an important person has died, and a comet will appear. But they're saying comets don't appear when beggars die. Now, it wasn't until almost 100 years later that Edmund Halley, the namesake for Halley's Comet, discoverer of Halley's Comet, observed a comet in 1759. From the observations, he was able to calculate that its orbit, what its orbit was, and predicted its return 75 to 76 years later. Now, tracing its appearance backwards in time, it was actually seen during the Battle of Hastings in 1066 and was taken to be a divine visitation associated with the death of the English king. And then Shakespeare himself would have seen Halley's Comet in 1607. So the inclusion of this unknown and ominous object would play a really dramatic, extremely dramatic role in one of Shakespeare's plays. And I totally agree with the comment that just popped up. Comets should appear for everybody. And who knows, maybe they do, maybe just they're faint ones and we can't always see them. Now, as I also mentioned, meteors, or shooting stars, were another astronomical phenomenon during Shakespeare's time that really didn't have a great explanation. The most common explanation was that there are stars that had somehow escaped their celestial sphere, maybe fallen off that celestial sphere, and then was then passing through the sky. And so we see quotes like, "Little stars shot from their fixed places, fly like chidden Mercury from Jove, or like a star disorbed." So disorbed, coming out of that spherical orb that the star was once a part of. Or in Henry IV, "An exhaled meteor, a prodigy of fear and a portent of broached mischief to the unborn times." Probably for the same reasons that meteors were like comets, in the sense that they were fearsome and ominous, something weird, something unexplainable, and so it was always associated with bad things. Now, unfortunately, Shakespeare died on the eve of a modern age in astronomy. In the few years after his death came significant advancements to telescopes, detailed observations of our solar system, and the development of theories that are still used today. I can only imagine, with the state of astronomy today and all the amazing discoveries we've made, what sort of art, what sort of amazing and the creative mind of William Shakespeare could have produced. Now, his love and understanding of the cosmos led to the poet Matthew Arnold to refer to Shakespeare as "thou who didst the stars and sunbeams know." His works suggest that he could even rival the majority of people in present day with his familiarity with astronomy. He's even been honored, astronomically speaking, after the discovery of Uranus in 1781, about 150 years after Shakespeare's death. Uranus was the first planet discovered by William Herschel. Uranus had, of course, been seen before. It's a pretty bright object in the sky, but it was thought to be a star. And so it required some advancements in telescope capabilities before it could be observed as a planet. Now, being British, William Herschel wanted to honor his background, and he wanted to name this new planet after the present King of England, George III. This did not set well with the global astronomical community, who wanted to keep the planet names kind of in line with Roman gods, Greek mythology, things like that. So after a lot of debate, a lot of arguing, a lot of nasty letters, Herschel finally accepted, and they all agreed on the name Uranus. However, a few years later, in 1787, Herschel discovered two large moons orbiting the planet. Herschel could think of no better way to honor his heritage than by naming them after two of history's greatest playwrights' characters, Titania and Oberon, the king and queen of the fairies in Midsummer's Night's Dream. While this too created a bit of a backlash with fellow astronomers, the names eventually stuck. And it turns out all subsequent moons that have been discovered have been named after Shakespeare characters. Now, I'm only showing 6 here. However, in this schematic diagram on the right, you can see all but 12 moons not imaged, and all named after Shakespeare's characters. In total, there are 27 moons of Uranus, all of them named after Shakespeare characters. So together, they give the works of William Shakespeare, "thou who didst the stars and sunbeams know," a permanent place in the stars. Now, I hope you've enjoyed my talk here tonight. I'll of course stick around and answer as many questions as I can. If you really were into this and you wanted to kind of keep reading on your own and follow up, one paper I relied on the most was this J.C. Dean paper from 1924, which is freely available to read. And then there's also the Science of Shakespeare book by Dan Falk. And if I'm correct, I feel like I've seen them perhaps lurking in the comments. So maybe you can answer some questions as well that I might not be able to catch right away. But again, thank you very much, everyone, for coming out. And I'm happy to turn things over for questions. Awesome. And it looks like there's a few questions here that I have missed. So Asher writes, oh, maybe I can close my presentation here so you can get a closer, so I can describe things a bit better. Asher asks, was the idea of celestial bodies being people/gods a common idea of the time when Shakespeare was alive? I definitely think the idea of stars having more of a less scientific explanation and perhaps something more theological was appropriate in the 1500s and 1600s. So hopefully maybe that's the question you're asking. And also, how does that fit into Shakespeare's generally scientific thoughts? Yeah, so that there's the double-edged sword there where he works that into his writings, but at the same time, he has these more scientific explanations as well. And so I guess the idea is that the way he was writing, he has to write for the general public to be interested and understand what he's trying to say. And so his writings had to reflect the beliefs at the time. And then it's just these little tiny passages here and there that I alluded to that shows, well, this might not be what he truly believes, or he might not necessarily not believe it, but he was aware that there were some scientific explanations as well. So I would say he worked it into his writings, both the science and the theological beliefs. Cool. Oh, thank you everyone for your comments. Yeah, Isabella, who knew? I had no idea that Shakespeare was so hardcore on astronomy. But when you start digging around in the research, a lot of people have kind of analyzed all of his works inside and out, and it turns out there's so much astronomy in there as well. So pretty cool. Cool, no problem, Asher. I love questions. Keep them coming if you have them. Cool. Thanks, Bruce. Thanks for coming out. Yeah, here I can. I'll put up my slide again, maybe here, if you wanted to see the reference, or maybe I can just put it in the chat. Let's see. So this was I just posted in the chat the link to the one article that I talked about, the Dean 1994, and then there's of course I don't have a link for the Science of Shakespeare book, but it's also a good read. Actually, yeah, I'd be interested to know the answer to Mary's questions to Dan as well, if there's any evidence that Shakespeare hung out with astronomers. To me, he had to have been at least attending some sort of talks or reading papers, but if he was connected, that'd be really interesting to know. Chris G asking, did he invent any words about the cosmos that we still use today? So that's a really good question. None that I came across. But that's not to say I thoroughly know the origin of every astronomical word. So that might be something I dig a little deeper on, because he definitely could have coined a few phrases at the time. But off the top of my head, nothing I came across suggested that. But cool question, Chris G.
I'll creep back in while we're waiting if anyone has any last minute questions or comments.
Thanks. Yeah, I can't imagine he missed the 1604 one. 1572, he was 8 years old. Maybe it was a big deal. Maybe people were talking about it, but it might not have been something fully registered with an 8-year-old. But yeah, I definitely agree. Definitely 1604. That was something he would have seen and been all over.
Oh, the real Dan Falk speaks.
Really ready. Oh, and that's very cool. Dan Falk, in case you didn't see it in the chat, looks like there's some evidence that Shakespeare was friends with a few astronomers. Very cool.
It appears we're getting quite a little sneak preview. Oh, and he's provided a link as well. I love that.
Yeah, cool. Thanks, Dan. Thanks for
thanks, Dan.
stopping in. That was cool.
You never know what can happen on Cosmos from your couch. So right. That's great. Feel free if anyone has any last minute questions, but in the meantime, I will just thank obviously Dr. Webb for coming tonight. And this was such an amazing presentation. It kind of, I didn't love Shakespeare in high school. Maybe I wasn't ready for it, but just even this presentation makes me, think while I'm still spending a lot of time at home, man, I gotta maybe pull out some of those things from high school, 20 years ago. It's getting to be a while or longer.
I expect you to email me 500 words by next Monday. Okay.
By next, and he'll hit me up on that. He'll hit me up on that. Okay. Sure. Game on. Sure. So like I said, anything. It looks like we don't have any further questions. So that's amazing. This was super fun tonight. Hope you had fun, Jeremy, as well. So I alluded in the chat that if you guys stuck around, I'd have a little tidbit of news that hasn't been released yet. I can't give 100% away everything, but if you're a fan of Cosmos from your couch, what we've been doing over the last 4 or 5 months, I think I calculated while Dr. Webb was speaking, I think we are this is our 26th episode. So I want you to go into your calendars and just put a little tick on September 12th, the evening of September 12th, no big deal. There is something big coming. We're going to announce it this week. If you love this, if you love games, if you've attended one of our presentations like Astronomy on Tap or Space Time in person, you're really going to love this. We're going to have games. We're going to be looking at the sky. There's going to be everything. It's going to be like a good old rock and roll. Someone did make an Oasis reference during about Champagne Supernova or Novae. But it's going to be like a little rock and roll variety show. Anyways, that's all I can say. So stay tuned. Make sure, if you're not already, follow us on Instagram. We're at the Dunlap Institute. Check in on our website, Twitter, Facebook. You can find us. And now that I've created the mystery, yes, by the end of the week, we should be announcing it. So officially, but like I said, September 12th, put that in your calendar. If you like what we're doing here, and it's going to be this, but bigger and better. It's going to be like this on, hyped up on lots of sugar and balloons and everything. So, that's exciting. Jeremy, you got to be here for the big intel. So I'm psyched. So we'll do one last check. It looks like, you've answered everything. Everybody is leaving satisfied. So unless you had any final words or, thank you for joining us.
Just a big thanks. Yeah, it was awesome. Thank you, everyone.
Yeah, that was super fun. So with that and leaving that excitement, and I hope to see a lot of the familiar names that we see in the chat every week over the last, X number of weeks. So that's been amazing. Like I said, we're bringing more to you. We're doing all we can. So stay tuned, and thank you, Dr. Webb. And I'll get started on my homework immediately. And,
Sounds good.
and we'll say